Hello, it's Lucas again. Welcome in another part of tutorial about the AstroLink device. This time I'm gonna talk about the temperature compensation of focuser position. As you know, during the astro imaging session, usually over the night, the ambient temperature decreases, and the instrument, telescope or refractor we have reacts to this, and the focal plane is moving. So during the session we need to adjust the focuser position to compensate its temperature, ambient temperature. How to do it in the AstroLink? In the AstroLink, in the focuser settings, we have the compensation tab. The first thing we need to do is to enable compensation, so we need to check this box, and then we have three parameters to input. First one is temperature compensation cycle. It's just a time that between each of the moment the temperature is measured. It doesn't make sense to use low value here. 30 seconds or even 60 seconds, like 1 minute, is pretty much enough because ambient temperature doesn't change so quickly. Another most important parameter is compensation, actual compensation. It's expressed in steps per degree. What does it mean? This value, for example, minus 120, means that when ambient temperature changes for 1 degree, then we need to compensate it by moving focuser of 120 steps. And that minus sign at the beginning means that when temperature increases, the actual focuser position needs to decrease, so it must be moved inside the focuser tube. Last parameter is autocompensation threshold, expressed in steps. This value is used when the compensation mode is set to automatic. So now when we start the temperature compensation, this temperature value is measured every 30 seconds and the compensation amount is calculated. So for example, temperature dropped by ½ degree, so it means that focuser must be moved by 60 steps, and when this calculated value of 60 steps exceed this threshold, the compensation will be applied when it's set to automatic. So let me show you how it works. I will choose second sensor to show you how it works, because I have placed it under the dew-cap heater, so now I can change its temperature easily. So now temperature compensation is on. I will turn on heater, and dew-cap heater currently is almost 12 degrees, but it should increase quickly, and you can watch the compensation amount window. I will change the cycle to faster, so the temperature will be measured more often. Now you can see temperature is increasing, compensation amount is calculated, and the value is increasing, and once it exceeds the threshold, like 60, the compensation is applied. I clicked by mistake, but again you can see it. Temperature is increasing, compensation amount is increasing, and it exceeds 60, it was applied. I will turn off heater. So this is fully automatic mode. The compensation is applied every time it will exceed the threshold. Now there is another compensation mode, manual. So in this mode, compensation is applied, compensation is calculated, but it's not applied automatically. So now you can see temperature is not changing. Oh, now it has been changed. Now it drops because I turned off the heater. So it drops and the compensation amount is like 30, and in a moment should be more, 45. Even if it exceeds the threshold, it will not change because it's manual mode. So we need to explicitly click the compensate button to apply the compensation. You can select any moment you want to, like for example between subframes to compensate position. You doesn't need to set focus again, but according to calculated compensation amount, you can click compensate, and now it's applied and it's being calculated from the beginning, from the scratch. So this is the manual mode. There is also third mode that uses manual mode. You can also trigger the compensation with the script. If you would like to see this script, how does it look like? It looks like this. It's actually a few lines of the code. You can check the manual for the actual code. The command, the most important thing here is a command set to AstroLink device. This command means that compensation must be applied, and the number means that compensation must be applied once the compensation amount, the calculated one, exceed this value. For our example, it's 60. So now, when I run the script, I just double click on it. Compensation has been applied, as you can see. It works the same like you click compensate button, and now it's 15 steps. As you seen before, the compensation threshold in the script was 60. So now when I run the script, it doesn't change its position because it's less than threshold. Of course, it doesn't make sense to click it manually, but it makes much more sense to use it in the imaging software, for example Maxim or Sequence Generator Pro. When you plan the session and you can put the script here in case of Maxim, in case of Sequence Generator Pro in some other window, you choose the script, and then the script is triggered after every subframe. So after every subframe, the compensation is checked, and if it exceeds the threshold, the compensation is applied. So this way you are sure that the compensation is applied only between subframes, not during the exposition. So the focuser is not moved when the exposition is in progress. This is benefit of using script. And what now, the quite important thing, how to calculate, how to estimate the compensation coefficient. Well, in the AstroLink device, there is a compensation calculator. So here, during this session, during the first session, you can just note down the temperature and the focuser position. For example, over the session you you set focus first time when the ambient temperature was -9 and the focuser position was like this. Then you measured focus again 1 hour later at this temperature and focuser position was this, and in the morning temperature was lowest and you again set focus and the focuser position was this. You can just enter here any number of points as you want to, and the compensation will be calculated based on these points. Adding points is simple. You just put values here and the compensation coefficient is calculated on the fly. Removing points is also simple. You just select the point and click delete button and it's removed. Once the compensation coefficient is calculated, you just can open focuser settings and put this coefficient here and then start to use it. Another option is that you can add to the table the current temperature and the current focuser position, so it's even easier. Then you can do it during the session, like clicking here. The point has been added. Of course, this point doesn't make any sense here, so I just remove it right now. And also there is one more option to calculate the compensation coefficient using the AstroLink charts. As you maybe remember, under this button there are charts when you can read the focuser position and the temperature in any moment on the session. After the session, when you have been adjusting focus points, you can just analyze these charts and note down the points, temperature and focuser position, and then these points you can copy to compensation calculator and then calculate compensation coefficient. This is it for today. quite a large topic, but very useful in the astroimaging work. Thank you and see you in the next part.